Okay, so in this lab, we're going to create our database from the topology. If I pull up the topology, and as a refresher, we've created a VPC within our infrastructure with the two availability zones, and each availability zone has a public and private subnet. And the public subnets are where our EC2 web server instances reside. And we're going to work on creating the databases in the private and public subnet. Okay, and also in the lab, we created an S3 bucket and how that can be used to host a static website. Okay, so we will go ahead and get started. Okay, so what you want to do is start the lab, right? So you're going to click on Launch AWS Academy Learner Lab. You're right. You want to click Start Lab. And while you're waiting for the yellow light to turn green, which should take about a minute, shouldn't take too long, but once it does turn green, you can click on it, and then you're taken to your console, like we are here. Okay, we've done that several times before. Okay, so how to access the database. Okay, in the search, you can type RDS, and that's Managed Relational Database Service, and click on it. And we're taken to the dashboard. And as you can see, you can create up to 40 database instances in a virtual private cloud. All right, we're not going to create that many. We're only going to create two. And so with that said, let's go ahead and get started. Now, before you create a database, the first thing you want to do is create a subnet group for the databases, right? So it'll be much easier when you create the database to just click on that subnet group, okay, to specify which subnets that database can belong to. Okay, so on this left menu here, if you scroll down, you'll see something called subnet groups. Click on it and select Create DB Subnet Group for Database Subnet Group. And we'll call it R-Database Subnet Group. And if you wanted to give it a description, I'm just going to copy and paste it. VPC, you want to choose your virtual private cloud, right? So it was the lab VPC. Okay, again, mine ends in EA5, right? These are hexadecimal numbers. So make sure you choose the appropriate lab VPC. Okay. Now, what we want to do is add the subnets to it. So we're going to click the drop down arrow, and we're going to choose US East 1A and 1B. And we're going to click the drop down arrow for the subnets, and we want to choose the even number subnets 2.0 and 4.0. Because if you look at the topology, right, the private subnet is in US East 1A with a 2.0 address, and the private subnet 2 is an availability zone US East 1B with a 4.0 address. Okay, so we got that selected, and you just want to verify and click Create. Okay, so you got the subnet groups complete, done. It shows complete. Now we can create our databases. Underneath the dashboard icon in the left menu, select Databases and select Create Database. Okay, now we're going to use the standard Create. And for the engine option, we're going to use Maria Database, which is a MySQL compatible database. And it's open source, which basically means the source code's available to anyone. It's not necessarily proprietary where you have a license fee for it. You can get a license for it. It depends if you want support and you want to pay for that support in some cases. I know Linux Red Hat does that. But in most cases, open source, right? It's free and there's no licenses that you have to manage. Okay, so Maria is a MySQL compatible database. We're going to select that. And you can click on each of them to learn about the databases, and they give you short descriptions of each. So you can do that. Pause the video if you wish, and then select Maria database. We'll leave the default version as is, okay? And it should be just the latest one. And from here, we are going to select the free tier. Now, here's the thing with the free, if we select development test, and again, we're not going to have access to do it because of the limitations on the AWS platform. But what I just want to show you real quick with development test or production, you can easily create the databases. You would just select create standby instance in a different availability zone, right? And it would walk you through the process of selecting those backup availability zones. Okay, so you could actually replicate what you have here. You would be able to create a standby instance in a private subnet 2 and specify that it reside in 172.16.4.0. With the free tier, you have to kind of do it manually. Okay, just some of our limitations. Okay, so I'm going to go back up and change this to free tier. And we're going to give the database a name. You can call it my database. And database has to have a username. And we're going to leave the username admin. Click on self-managed if it isn't selected already, because we're going to create our own unique password. Now, if it was a production database, you would obviously choose passwords that are more complex and that are in compliance with your organization's password policy. Okay, for the purposes of the lab and just to make sure that you can log in okay, we're going to create simple passwords. The password will be 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's very weak, but we have to have 8 characters, and we'll confirm it. 1, 2, 3, 4, 6, 7, 8. Okay. Okay, now you want to select burstable T classes if that's not selected already. And you can go to DBT3 micro. You can leave it at 4, that's okay, but you can select 3 micro. Storage, you want to leave it as is, right? If this was a production database, obviously you need more than 20 gigabytes of storage, right, on a large database. But for the purposes of the lab, we'll keep the storage as small. We'll keep it at 20 gigabytes. Okay. And notice the multi-availability zone deployment is not selected for us, right? It's grayed out because we're choosing the free tier. So it's just one of the limitations. We don't want to automatically connect to an EC2 compute resource. We want to do that manually. And we want to set up the security groups that allow us to do that. You want to make sure your database is in the correct VPC. So you don't want the default VPC. You want your lab VPC. Okay, should be 4 subnets and 2 availability zones. Okay, so make sure your lab VPC is selected, not the default. Okay, subnet group. Okay, so notice the one we created is automatically selected. It was called our database subnet group, which consists of 2 subnets, right, and 2 availability zones. Public access, no, we don't want public access because the private instances reside in private subnets and have private IPs, okay? So only the EC2 instances would have the public IP address because they would be the front end, right? And we talked about this in a previous lab. So you can install the application on the EC2 instance, and as end users type in information on that application, it gets sent and stored onto the database. Okay? All right. Choose existing security groups, right? So we're going to have to create a new one. And once we create a new one, we'll have to edit it. Okay, we'll call this database security group. And we're going to have to specify an availability zone for it. and we'll select US East 1. Okay, we'll leave the certificate authority as is. We want the password authentication, just authenticate using the passwords we created just now. Okay, and then select create database. Okay, so it takes, yeah, password is found in a data breach. Yes, because it's very easy, okay? It give you suggested add-ons. We're going to click close for that, okay? And it takes like 5, maybe to 7 minutes for this database to be created. Okay, so what we need to do is eventually the EC2 instances need to access the databases on the private subnet. So we want to allow connectivity. We want to allow inbound connections into the EC2 from the private subnet. Okay. And likewise, we need to connect to the EC2s via SSH. So for now, we're just going to allow a very open rule that allows any IP address via SSH to connect to the EC2. So we need to kind of look at our security groups. And we created one for the web servers. So let's just look at that security group while we're waiting for this database to be created. Okay. Now we'll click on services, or we can just type search. We could type EC2 and click on EC2. And we'll click on security groups. And what we want to do is select the web server security group. Okay, now notice the only inbound rule we're allowing is, let's go edit inbound rules. Okay, well, for some reason, I guess we're allowing all traffic on the EC2. Okay, I thought we were only allowing port 80 traffic. At least that's what I thought. Let me make sure I'm not looking at an old security group. Just hit the back button. See how many security groups we have. Okay, we have the database security. We'll need to edit the database security group. Okay, we'll do that once the database has been created. Okay, so the web server security group, we're going to kind of fix this. Okay, we're going to click on it. We're going to edit these inbound out. I'm sorry, we're going to edit the inbound rules. Okay, never mind. I see what I did. I forgot to click on inbound rules. We're going to go to edit inbound rules. So make sure edit inbound rules tab is selected. Then click edit inbound rules. And as you can see, yes, port 80, we're allowing inbound from any IP address. That's fine. You could add a rule that allowed HTTPS as well, which is port 443. And you can allow that from any IP address. And we can click add rule, and we're going to allow SSH from any inbound address. Okay? And this will apply to both Web Server 1 and Web Server 2 because they're both in the same security group. Okay? Now let's check outbound rules. Okay, so let's just see the outbound. Let's click edit, see how it reads. Okay, basically we're allowing all outbound traffic. Okay, so that looks good there. And we'll just save the rules. Okay, and let's just go back, hit the back button on your browser till you're back to your security groups. Okay, now let's see, the database security group is something we need to edit. Okay, so let's just click on the security group ID for the database security group. All right, and outbound rules, traffic leaving that private subnet can go anywhere. Okay, if you want to be more restrictive, okay, the private subnet is only should be communicating with the public subnet. Okay, because again, it's the back-end database. has no need to connect to the outside world, right? And again, I explained in a previous slide, you could set up a NAT gateway here, and the privates in the databases could connect to the NAT gateway if they needed software updates, etc. Other than that, they don't need no access to the outside world. So we only want to allow outbound and inbound connections to and from the public subnet. So we can actually edit the outbound rule. Okay, so we're going to click on this, right, where it says custom IP, and we're going to change that to 172.16.0.0/16, which is anywhere in our VPC, okay? Because if you look at the topology, our VPC is 172.16.0.0. Did I put /24? No, I put /16. Okay, so that's set up correctly. Okay, so that's the only outbound traffic it's going to allow. This would actually prevent the databases from trying to access the internet, right? Now, when we set up the NAT gateway, we're going to have to edit this rule, okay, to specify that any other traffic would go to our NAT gateway. And then we're going to select Save Rules, okay? And that's our outbound rules. We're going to click on Inbound Rules. And we're going to click Edit Inbound Rules. Okay, now notice this IP address, right, which is a specific IP. We only want to allow inbound traffic on port 3306, which is SQL, from the EC2 instance or from the VPC, right? In other words, going from here to here, okay? Because we're going to connect to the EC2 instance, and once we're connected, we're in, right? Now, once we're logged on to the EC2 instance, right, we're logged on with the private IP internally. And from this internal IP address, we should access the private subnet on port 33, the private database on the private subnet on port 3306. So we're going to change that to, again, 172.16.0.0/16. Okay, and then we're going to click Save Rules. Okay, and that should update it. So our outbound rules look good for the database security group, and our inbound rules look good. Okay, so let's see if the database has been launched yet. We're going to type RDS, and we're going to click on it. Okay, and under the dashboard, notice it says 1 of 40. Go ahead and click on that. And now it's available, okay? Now let's just make sure that it has been assigned that security group. Click on My Database, and notice under Security, it should be assigned to Database Security Group. And you can kind of, look, you can verify the subnets, and you can verify the VPC. And so you click on the Database Security Group, and you can click on the security group ID, and you can verify those inbound and outbound rules. So again, right, we changed it to 172.16, and then the outbound rules, click on the outbound rules. We're allowing all traffic, right, outbound from 172.16. Okay? And that keeps traffic within the VPC. Now I'm going to hit the back button once, twice. Okay, and you're back to My Database. Okay, what you're going to do here under Connectivity and Security, you're going to see a database endpoint. Okay, now that the database is available, click on that endpoint, and then it's copied. Okay. Next thing we want to do is connect to our EC2 instance. So we're going to click on the EC2 instance, or we're going to key it in, EC2, and click on it. Click on Instances Running, which is 2 of them. Okay, now we updated the security group to allow inbound SSH connections. So we're going to do web server 1 first. We want web server 1 to be able to communicate with the database. So click on web server 1, and at the top here, click connect. Okay, and they're warning us port SS8, the port 22 is open to all IPv4s. And just say connect using EC2 instance connect. And then from here, leave the default username. It should read EC2 user and select connect. Okay, and now you're logged into the Amazon Linux 2023 EC2 instance. Okay, so the first thing you want to do is, we can perform a security update by typing the command sudo, which means to run commands as an administrator without logging on as an administrator. Type sudo dnf space update -y and hit enter. Okay, and you may get a nothing to do because the updates may be all good to go. Okay, the next step we're going to do is install the Maria database. Now, I've already installed it on this. Okay, I was working on something else in a previous lab. But to do the command, I'll walk you through it. You're going to type sudo space dnf space install space Maria db 105 and hit enter. Okay, it's already installed. You see, I got the notice. Yours will be actually installed. Okay, the last step you're going to do is connect to the database from the EC2. So if you look at the topology, just to give you an idea where you're at, you're logged into the EC2 right here. And what you want to do is connect to the database in the private subnet. Okay, and we're going to use a SQL command to install it. I mean, not to install it, to connect to it. We've already installed the Maria SQL client software with this command right here. So how do you connect to a database? You type the command mysql, hit the space, type -h for the host, that's what that means. Right click and paste as plain text the endpoint, hit the tab, hit the space bar. Type -P without any spaces. Try that again. No space between the dash and the P. That's the port number. And you want to specify 3306. That's the port you're going to connect on. And that's the port that the database instance is allowing you to connect on, right? From any 172.16 private IP. Hit the space bar. Type -u, which is for the username, type admin, hit the space bar and type a -p and hit enter. And it's going to prompt you for the password. If you remember, our password was 1, 2, 3, 4, 5, 6, 7, 8. Notice it doesn't show you the characters. Hit enter and you're logged into the Maria database, and you can see that right here. Okay? So that completes the first part of the lab, and what we can do is create a second database instance in the second availability zone. Let me pull up the topology here. And again, so this EC2 instance was created from a machine image that we did in a previous lab. So we're going to kind of repeat the same thing, only we're going to create a MySQL Maria database in private subnet 2. Okay, so we will minimize this. And to exit out of here, you just type exit once. That logs you out of the database, takes you back to the EC2 server, and exit out of the EC2 server by typing exit again. And you should see a log out. And then you can close the EC2 instance connect tab. And then you're back to your instances. Okay, so we're going to kind of just repeat the process. Okay, we're going to go ahead and select RDS, and we're going to click on it. Now we got one a 40 running. We're going to click on that. You can do it two ways. You can click here or you can click here, and you're going to create database. I should have named it My Database 1 and My Database 2. Oh well. Okay. We're going to leave standard create. We're going to select Maria Database. Leave the default engine. Select free tier. And we're going to give it a name. We'll call it My Database 2. See, that's why you have to be careful with your naming conventions. And I know we're doing it in a for lab purposes, but you really have to write this stuff out when you're going to name things and you're going to give things tags. And I think we talked about that in a previous lab. You know, even with planning your IP v4 addresses, same thing with your naming scheme. Okay, you want it consistent throughout. Something that's going to make sense. Okay, the credentials will leave the same. We'll call it admin. Leave it as self-managed or click on self-managed. And for the password, we'll type 1, 2, 3, 4, 5, 6, 7, 8. Confirm it 1, 2, 3, 4, 5, 6, 7, 8. And we'll select db.t3 micro. We'll leave the storage type as is. Okay, we don't want to connect to an EC2 compute resource. And the network type will be IPv4. Make sure we select our lab VPC. It's not the default, the lab one. Okay, you want the subnet group, right? So you want to keep that same subnet group. No public IP address. Choose an existing security group. And again, it'll be the database security group. You want to uncheck default. So make sure you only see database security group here. Okay, make sure the check mark's taken off the default. Availability zone, it's going to be different now. You're going to place it in US East 1B. Okay, certificate authority, you're going to leave as the same. Password authentication, you're going to leave as the same. And you're going to select create database. Now, the good thing is your security groups are already set up, right? And the same rules for the first database we created and allowing only inbound connections from 172.16.0.0 on port 3306. That's the only thing we're going to allow inbound. Outbound, anything's allowed outbound within the VPC, within 172.16.0.0. So we don't have to repeat those steps. Okay, we're going to click this close button here, and we're going to wait for that to be created. Okay, but that database is going to belong in the same security group as the first database we created. Okay, so with that said, right, and then the web servers belong to the same security group. And again, we've edited the security group for the web servers to allow incoming port 22 SSH connections from any IP address, right? So we edited that security group as well. So it was only a question of creating the database. So again, you got to see how the security groups work when you're adding additional objects into the cloud. Okay, now again, it's going to take some time for this database to be created. And what we're going to do for now is I'm going to pause the video and wait for this database to become available. It's probably going to take about 5 minutes. Okay, so the database too has become available. And what we'll do is we'll connect to it from web server 2. Okay, so we will go to the dashboard. In fact, we'll go to services and we'll select EC2. Click on instances running 2. Select the web server 2 and we're going to click connect. Okay, it's warning us that port is open to all addresses. Okay, the username, we're going to have to change that. It shouldn't be root. It should be EC2-user. And we're going to select connect. Okay, as you can see, we're logged in as EC2-user. Okay, so to repeat the steps that we did earlier, we'll perform a security update, sudo space DNF space update -y, complete. Then we'll install the Maria SQL client software, sudo DNF install Maria DB 105. And we're going to select Y for yes and press enter. Okay. And then we're going to connect to our second database instance. So we need a database endpoint for that. So we've got to go back to RDS. Should have done that before. Click on DB instances. We got 2 of them now. Select My Database 2. Click on it. I'm sorry. And click on the endpoint. And it'll copy the endpoint. We'll go back to our console, EC2 console, and we'll type the command. We'll log into the second server. We'll type MySQL space h-h, which stands for host. Hit tab key and hit the space bar. That's the endpoint you copied in. Dash capital P without any spaces, 3306 space dash small u space admin space dash P. Hit enter, and we're going to type 1, 2, 3, 4, 5, 6, 7, 8, and hit enter. And then you're logged in to the Maria database, and this is the second database server that we set up. Okay, now to log out, we'll type exit, and to log out of the EC2, we'll type exit. Okay, so we're almost done. We've got a couple more things we got to do. I wanted to show you how to create the databases in each availability zone. So you had some practice there in doing it twice. Okay, what we ideally want to do is we want to create a read replica. So the data that goes into the private subnet 1 database is replicated to the private subnet 2, because right now they're just 2 individual databases. Okay, so to enable the replication, what we're going to do is delete the second database. So you're going to click on it. You're going to go to the Actions menu, and you're going to select Delete. And creating the replica won't take that long. It'll just probably take a couple, 2-3 minutes at the most. It's not much. And then we'll select Delete. And it's deleting the My Database too, okay? Now, while that's deleting, okay, we're going to go back to our original database, which is My Database. And from there, okay, now just take a look at the topology, right? This is My Database in the private subnet 1, right? 172.16.2.0. We want to create a copy or a replica of it in the private subnet 2, okay? And it's not going to be a standby instance, it's going to be a replica, okay? And so from here, you select the first database we created, which is My Database, okay? Click right here, go to the Actions menu, and select Create Read Replica. Okay, now from here, we're going to go, and the replica source is going to be My Database. Okay, now you're going to give the database a name, and we're going to call it we'll call it My Database -replica. Okay, and this will be the name of the database that's created from the My Database. Okay, we'll leave the default DBT3 micro as is. Make sure we're in the U.S. East North Virginia region per our topology. Storage will be the same. Okay, we do not want to create a standby instance. Remember, we're operating on a free tier. So to keep our costs down on that $50, we're not going to create a standby for now. We'll just have a replica. And from here, we'll scroll down to net connectivity, IPv4. Notice we already have a subnet group, so we're good there. We have already specified the subnets and the availability zones. And the existing security group, we want to make sure we have a database security group because, again, we're allowing inbound port 3306 connections. Okay. The availability zone, we want it to go in US East 1B, right? So we want this replica to reside in the 1B area. We'll leave certificate authority as is, password authentication, okay, as is. It's going to be the same because it's going to be a replica. And we will go to for now, we'll take this off, enable auto minor version upgrade. In the real world, we'd want to leave that checked. And we'll select create read replica. Okay, so you're getting a replica being created. And you can see like how this points, the my database points to the replica. You have a primary in the US East 1A, and you have a backup, right? Or a replica in the US East 1B region. And while we're waiting for the second database to be deleted, okay? The video's basically done. I'm going to go through some steps with you to make sure that we turn off unnecessary services. I'm only going to pause the video and wait till this second database has been deleted, okay? Okay, so the second database we created for practice purposes, right, was deleted. And then we did create a replica in that second availability zone. So our topology kind of shows this is the private, the database in the private subnet as a replica. So with that said, right, trying to keep costs down here, right? So if you wanted to launch the primary database in a multi-availability zone environment, from the actions menu, you could go convert to multi-AZ, right? But then again, we're running into costs, and so there's many more labs I want to create, and I want to keep the costs under $50. But if you wanted to do that, all you would have to do is either select apply during the next scheduled maintenance window or apply immediately, and then click convert to a multi-availability zone, and then you would have two databases in separate availability zones. Okay, but right now we have a replica, which means anything that goes into the primary gets replicated into the secondary right here in US East 1B. All right. So what we want to do is just simply temporarily stop our databases and our EC2 instances. So we want to click stop temporarily. Okay, it says it starts automatically a week, right? I'm doing this video on 30 September 2024, and it's going to restart automatically in a week. So go back in there. When we pick up on the next lab, we'll take a look at the status of the database instances. And we don't have to save it as a snapshot. We have nothing in there. Snapshots are created automatically of the data. So we'll just click stop temporarily. Okay, so it won't start it for the read replica. That's okay. Let's try if we can do it here. Nope, it's okay. So with that said, what we're going to probably do is let's go ahead and we'll delete these two instant. You know what? We're going to leave them in there. We'll leave the databases in there for now. What I want to do is go to the EC2 instances. So go to EC2 and we'll click on instances running. Click on web server 1, and what we're going to do is stop the instance. Okay, and we don't have an elastic IP, so we're good there. Click on web server 2 and select stop instance and select stop. Okay, and those instances are being stopped. Now let's go, make sure you don't have any S3 buckets from your last lab. So click on S3. You may have to go here and click on buckets. Okay, you should have no buckets. If you have one, you can go ahead and delete it by clicking on it and just go delete. And if it tells you that there's objects in there, again, just go to the objects tab, delete the index.html file, delete that, then go back in here and delete the S3 bucket. And so what we'll do now is we'll log out of the lab and go back to your Academy tab, right? And let's just refresh this and let's take a look at our billing. Okay, so we're good there, right? 40 cents out of $50. We're in solid shape. And from here, you can go end lab. And that concludes the lab.